Hello everyone, welcome back to my YouTube channel, and this is our lecture number 2 for optimization technique. And today we are going to discuss about the content is nothing but basic optimization problem formulation, or we can say this is in some another way, that is statement of optimization problem. Either you can call it as a how we can generate a statement of optimization problem, or the thing is basic optimization problem formulation. So look at here how we can proceed for this. I have plotted here a figure is nothing but a container having cylindrical shape. The diameter of this cylinder is given, or height of the container is given. You call it as of cylindrical shape. And I would like to take a good example of a casting problem. This is the container is given to you, and the designer has made this container, and the instruction for a manufacturing team is like the height and dimension, and the figure is given itself for a manufacturing team. But the important thing is what the survey of customer survey suggests that I would like to the capacity of the container should be a 1 liter capacity. It will hold the 1 liter of water. That will be the capacity of container. So I'm going to enlist here what the needed things that designer team look like. These are the surveys before going to develop a component. So customer survey according to the customer requirement, what customer require at least hold 1 liter of water or 1 liter of the liquid capacity. So I will write here. I'm going to write here. Look at hold. My first thing is what it should hold at least. I'm writing at least 1 liter. 1 liter of water. It should hold at least 1 liter of water. So this what it indicates the capacity, or you can say the indication. The first thing I have written the capacity of water. Next I wanted what we will think as a manufacturer team will look out the minimization of cost. Definitely we have discussed in the earlier stages of first lecture of optimization. We have defined optimization in various methods, various defining process, and in that case we have think on the maximization and minimization the function. So what minimization, you should think like minimize the cost. Secondly we can think minimize the cost. Okay, now some design aspects I need to give such a design aspects to manufacturer team. So within that limit or within that constraint I should follow, and then I can develop or then I can manufacture the component. Though this is the height and depth is given to design team to manufacturer team, but I need to give some constraints. Yes, so what I want the range for the constraint like this. If I vary like this, if I would like to take the diameter ranges, it should be greater than 5. It should be greater than 5 centimeter. Diameter should be greater than 5 centimeter or less than, if I would like to take 10 centimeter. The range is given. Yes, whatever is your diameter, you should limit. Minimum will be a 5 and maximum will be like 10. Either 5 and in between 5 to 10. So this is the diameter. If I want to take again height constraint, what I will like to take. Suppose you can take any value, that if I will take 12 to 20 centimeter will be my height. So these some parameters or the values I have assigned. So don't go for the values, understood the concept. Okay, don't go for the values, just understood the concept. 1 liter hold the liter capacity of water. That container having maximum capacity should be 1 liter. At least 1 liter I needed. At least. Okay, not a maximum. At least 1 liter. Then these are second thing what I will look like. Second thing is minimize the cost. Means you have to think on manufacturing process. So on that cost will be a minimizing. And the constraint, this middle data is nothing but the formulation of constraint. within that limit or within that tolerance you should develop the your container that is in cylindrical shape. Now next thing, okay, so how, with the help of this data, how we can formulate our problem, how we can formulate. So formulation is entirely depends on the parameters we are assigning. What first parameter suggest? Look at your first parameter. It gives me volume. Yes or no? This first parameter gives me volume. That is nothing but if I am assigning it as a V, volume in terms of V. Okay. Now what is my next step? Minimizing the cost. In case of minimizing the cost, what I am planning, cost will be minimized in manufacturing, during manufacturing. So this is nothing but manufacturing. I am writing over here. This tells me manufacturing. So manufacturing is nothing but whole. What comes here? Volume is here. This is volume. This stands for volume. So what it stands for? Manufacturing of a cylindrical shape or this container. What I think, if I need to manufacture within a minimum cost, manufacturing, I would like to think the cost is my first primary aspect, but you have to focus on surface area. Okay, what I mean, what is manufacturing correlate with? Surface area. If the surface area is a large, your manufacturing cost will be large. Surface area is minimum, the cost required for material is minimum. Cost required for material, cost required for processing, cost required for any other things that are relevant to the manufacturing. Okay, manpower, these all the things you are going to consider for manufacturing. Now next, now if I am talking about what will be the volume, what will be the volume, that height and diameter is given. So volume is nothing but pi by 4 d square into what? Height. This is the area into the height, that gives me a volume. And if I am talking about manufacturing, I needed surface area. Surface area is nothing but what? How I can define the surface area for this thing? What will be my surface area? Surface area is depends on this. What is this? Pi d h plus this container surface area, this surface area plus this area and this area. These two circle areas, these are nothing but circle area pi by 4 d square, but there are two circles. So what I get? Pi dh plus pi d square by 2. Ultimately, the surface area is nothing but pi dh plus pi d square by 2. Okay, this is my volume and surface area. Now I am going to formulate. So for formulation, I need here, my primary task is minimum. What is my minimum? Primary task to minimum cost. This is the formulation, not a maximize. I don't want a maximization here, because the given data suggests me minimize the cost. So my function will be look like minimize cost. Now next thing, how I can minimize in terms of, here the parameters are given. You take a diameter and height. If I want to minimize, I need to think on what is the minimization required. The minimization function is this. What? The minimization function is this. What is that? Pi dh plus pi d square by 2. So this is minimization cost. If I am talking about surface area required for manufacturing, so definitely this will reduce in the manufacturing cost. This means the surface area required. According to that surface area, your cost will be this. If surface area is less, your cost will be less. If surface area is high, your cost will be high. So my cost estimation defines my surface area. Okay. Now next. So this entire, what is it? This entire is nothing but my objective function. My objective function. This entire is nothing but my objective function. sorry, this entire is nothing but my objective function. Okay, so this whole is my objective function. Now I have defined my objective function to minimize cost, and that is totally depend on surface area of container. Okay, now what is next task? Only the objective function itself needed you? No, you needed some another parameters for optimization. First parameter is objective function, either minimize or maximize, but here we get it is a minimize. It's totally correlated with the cost. So now next step, this objective function I am wanted to subject to so subject to what? Subject to what? I need volume, I need capacity, container capacity will be like to 1 liter. I need 1 liter capacity. So subject to is nothing but before this is my objective function, but you don't forget my subject to or subjective. What is my subject to? That is volume, and volume is greater than or equal to 1 liter, because I have mentioned intentionally what is the capacity of container, at least 1 liter. At least minimum will be a 1 liter, more than that definitely if it is I don't have any problem for that capacity, but if less than 1 liter definitely there will be a problem. What my strategy or what I have get the statements, hold at least 1 liter. So subject to volume, at least 1 liter is nothing but equal to or more than it, not less than. So this is my subject to. Then so if I want to write in terms of formulation, my volume I have with my volume pi by 4 d square h greater than or equal to 1 liter. This is the formulation. Now next thing, I have some constraints given, sizing constraint that we are actually called in this numerical sizing constraints. And what are the sizing constraints? This is my sizing constraint. Already we have these parameters are given. This sizing constraints is given to you. Objective function is itself given to you. Subject to is also given to you, and then you need to develop your solution, optimal solution for the such a kind of problem. But in a theoretical, to understood how the problem formulation is there, we have taken such a good example from casting. So how the manufacturer or how design team look like. This is whole entire process is concurrent process, not a sequential, not a traditional. Before what will happen, the traditional engineering is there, sequential engineering is there. What the barrier is, what the wall between the department is the barrier, because the design team gives the all over data to manufacturer team, then manufacturer team gives to the sales, then sales will give to marketing team, but the interaction is not there. So lot of problems are arises during this traditional engineering process. But the thing is what, right now we are following concurrent system. Entire team, all teams are sit along one table and they will decide entire strategy. What is concurrent engineering? Simply whole teams, design team, manufacturing team, then testing team, then the team of sales team, then marketing team, these all teams are sit together and they take a very good decisions, they develop their strategies. So this whole scenario is happening on the one table. So we actually call the concurrent engineering is the best source of engineering rather than traditional or sequential engineering. Okay, so you during this optimization technique, this seam concept is very much important. Seam concept is very much important. Okay, computer integrated manufacturer, that in that case or CAD case, we have studied this concept like traditional engineering, that we call actually sequential engineering. But how the traditional or sequential engineering is different from concurrent engineering, this is a very good example. All the teams need to think on only one table, or only you have to take a decision on as a team. Whole 5 team will take a decision and then they will proceed for design, for manufacturing, testing, and then so on likewise. So the decision constraints or sizing constraints. What the sizing constraints are given? You are having the sizing constraints as diameter will be follow 5 or 10 centimeter. This will be my diameter range, or height will be follow like this 20 centimeter. And you can call these are the constraints, or what the constraints indicate. These are nothing but sizing constraints. Sizing constraints. So I think you have understood how the problem formulation is there, or how the basic problem formulation for optimization. You have to define first objective function, then you have to go for what are the subject to. First is the objective function, then second is subject to, then the third one is sizing constraint. So these three are very much important factors, or non-negative constraints are also there, just like this. Simply h comma d are greater than or equal to 0. This is the non-negative constraint. This is the type of constraint that is non-negative constraint. That every numerical you will see the non-negative constraint, like in x1 and x2 is not is greater than or equal to 0. These are the non-negative constraint. So what is the decision variables? Only one parameter I want to discuss here, decision variable. So I will eliminate this. What decision variable? Look at, for decision variable is nothing but like this. If I need to take this as my height and this as my diameter, so diameter will start from 5 and diameter will varies up to 10. This is my decision variable, and what, or I can call it as design variables. Okay, and height will start from 12 centimeter to 20 centimeter. So these indicate, this is my design variables, or we can call constraints also sometimes. And this subject to pi by 4 d square is greater than or at least 1 liter, objective function, sizing constraints, or you may call it as a decision variable, design variables. So this is nothing but entirely basic optimization problem formulation. So I have discussed one casting problem with you. If hopefully this will this problem is you will like this problem. How we have proceed, how we will take one such a example of daily base application, and such a kind of a good example, or we can take a example from strength of material like a cantilever beam. You can take a cantilever beam example, formulate the objective function, the decision variables, formulate the non-negative constraints. Likewise, by taking the strength of material example, or we can take example from heat and mass transfer, design of fins, heat transfer rate through fins. Actually, this is also very good examples. Lot of examples are available from daily applications in the mechanical design aspects, but we have taken a manufacturing good problem, that is from casting, and we have discussed this strategy through this problem, through this numerical. So this will be a very easy to understood you how the problem formulation is there in optimization technique. Actually, this is happens likewise. You have to develop your own problem formulation. Apart from this, in exams they will give you directly problem formulation, all the statements, and you have to solve for optimum solution. But this is the theoretically, if they ask you what is, how you can define a problem formulation in basic optimization in the theory equation. So you need to give such a kind of good example from the subject I have mentioned, strength of material, cantilever beam, manufacturing, casting itself, whatever we have discussed. Either you give an example from fins, that is from thermodynamics, or we can call from heat transfer. So various examples are given. You can develop such a kind of good example by your own, and if you have such a kind of example, discuss with me in the comment box. Thank you very much.